doing fine in this pandemic and everybody is safe. Okay. I hope you enjoyed all the previous session as well. And this is the last session of our series ABCL. So let's get started. Okay. Dynamical systems are complex in nature. So dynamical system means suppose a moving car. It moves with respect to time. Well, it's very hard to code it and it is a very time consuming and tedious job. Thus, we have find out a simpler way to stimulate and analyze the system. As I have taken the example of unmanned cars, so we'll take things into consideration the followings, which are of four: analyze, communicate, computation, and visualization. Okay, for first analyzation, the car itself analyze its surrounding. For example, which kind of road is it? It is a traffic jam road or a highway road, or if there is a speed breaker. The second is communicate. So whenever it detects a car in front of uh, it, so we use horn to communicate to them that the car is behind it as well. And the third point is computation. It computes the speed according to which it has to go. And the last point is for us. So we'll be able to observe the output of the reaction of the unmanned car. So how do we do it? We do it with an interactive system, which in this unmanned car is a non-linear dynamic system, right? So it can also be used for linear, non-linear, continuous time, discrete time, multi-rate, and hybrid system. Okay, so it is also used for certain specialized applications such as communication, signal processing, and power system. And so there are certain features will be used in it. So what is it? It is a Matlab Simulink. I'll directly go to the definition of it. It is a graphical mouse-driven program that allows you to model a system by drawing a block diagram on the screen and manipulating it dynamically, which is a Matlab Simulink. I hope I'm audible to everyone and everybody is able to understand what I'm saying. Please reply yes. Yes, I'll be telling Darshan your point further. I'm just going to the explanation right now. I'll be coming to it. Well, we have completed our explanation, so we are going right now towards. So after this, what you'll able to learn, I'll first tell that. So which is the certain points which I'm going to read out again. Develop Simulink models in a practical, fun, and easy way. Develop, stimulate, and analyze electrical and mechanical system in Simulink. Understand the basic concept of control system and develop your own controllers in Simulink. And lastly, impress future or current employers if you have marketable skills in Simulink. That is certainly for us future. Okay, so okay, let's go to first MATLAB itself. Is everybody is able to see my MATLAB screen? Please reply yes. Thank you. And okay, so this is the MATLAB screen which we'll require, and it certainly takes time for my laptop's MATLAB to open. That is why I have opened it previously. So over here we can see a command window, and at the right side we see a workspace, and this is the editorial window. Let's type something in command window. Let's say a equals 5. Over the workspace, we can see a equals 5, where a is the variable and b is the value. And then we'll again type in the command window b equals 10, where we can again see b equals 10 and b is the value. Okay, I'll go slow. where b equals 10, b is the variable, and 10 is the value, where goes c equals a plus b. I have got over here 15. We can again see it in the workspace, c equals 15. Okay, this was the basic of MATLAB. I hope you know more than that because of your first year's courses in the college. Now we'll go to the Simulink. As here, we can see a Simulink. When you will click on it, you will see a pop-up window like this. Simulink start page. This also takes time to, so I have given a screenshot in the presentation itself. Okay, so over here we will observe over the left side the recents, the all the projects I have made it, and over the down we can see show aerospace block set, audio system toolbox. There are certain applications for aerospace dynamic and all, so they'll be using certain complements over here. And again, we are seeing in the Simulink, as this is a basic Simulink session, so I'll be going for the basics only. So when I double click on the blank model, a pop-up window will come like this. Okay. And over here, we are going to draw the components. Is this visible? Please reply yes if it is. Thank you. And here we can see that over here, this is a library. When you click on it, we'll able to see this. It is a Simulink library. Okay. In Simulink library, it is basically used for mathematical operations. The tools, the components which we are going to use, we'll just click it and drag it and drop it over the page, right? So let me tell you about Simulink main library, okay? Because we are going to use main library because the other ones are advanced ones. So I'll first go with source. As the name suggested, this source is for giving the inputs, right? So for example, we can see a ramp function, we can see a sine function, a step function, there would be a constant also. Well, all these fours, we are going to use them, okay? If we are given the output, if we are given the input, so we always desire to get the output. For getting the output, we go to sinks. Over here, we can see a scope, right? The scope is used to give the output in form of graph, okay? And next, we will go to continuous. Over continuous, we can see different mathematical operations over here, which is derivative and integrator. Please mute your mics, please. It's difficult to me to concentrate. Thank you. Okay. So over here we were talking about derivatives and integrator. We are going to use it in a few in the certain projects we are going to do. And lastly, we are going to use in commonly used blocks. See, for example, it's a gain, where gain, let's say if a signal has to be multiplied by 3. So if we add a gain and we'll give its value 3, so the output will be multiplication of 3 of the input. Okay, cool. So, so here are the 4 projects we are going to do. So let's get started. The first one. If you have any doubt, please mention it in the chat box. I'll be always looking in the chat box. So the first project is generate, display, and export source generating sine waves. After the project, you'll able to know how to select block from Simulink library, add up and view 2 signals in Simulink, generate sine wave and tune its parameter, change the model configuration parameters, export a variable into the workspace and plot it, magnify a signal using gain multiplier. Okay, let's get to the model. And this is the new model which I have uploaded and I have saved it beforehand. If you want to save it, click type Control plus S, and for saving it, you have to give the extension of SLX. I'll write it over here in the chat box. Extension of SLX to save a Simulink Matlab model. Okay, so over here, let's start the first one. I'll call the library over here. So first thing, we will get input, which is a sine wave. So for sine wave, we have to go to the sources. Are you going to do anything new other than Simulink on RAM session? I'm just giving normal core projects with able to understand the basics of it. Thank you. Okay, and we'll go to sources as where were we? Sources. We will see sine function which is over here. If we click, drag and drop it over here with the left key, you will able to see a sine function, right? If we have to take a multiple sine function, then right click on it and drag it down like this. So we get 3 sine function. If we have to change its value, then we click on it and we can see a window coming up there and it's giving all its amplitude, frequency, phase. So I want to keep it as amplitude as 1 only and frequency as 1. Okay, so I'll just type OK, click OK, sorry. And for second one, let's say I want to keep the frequency as 5 hertz, rads per second. Okay, and the third one as 10. Okay, now we have given the input. Now we'll give how to see what is the output. For that, we'll go to sync and we'll take the scope and we'll drag it and drop it. As we can see over here, there's only one input arrow, but we have to give 3 inputs. So we double click on it. When you double click on it, a pop-up window will open. It takes a little time though. Okay, when we'll go to settings and we'll see the number of input ports, which is over here 1. But we have 3 inputs, so I'll type 3 and I'll click OK. Okay, we'll close this one. Now, if we zoom it, we are able to see there are 3 inputs. Okay, now we'll connect all of it. Just left click and drag it to the arrow where you have to connect it. Similarly, this one. Am I able to, is everybody able to understand? Please reply yes or no. Thank you. So we'll run it. The program has run and it's ready to show. So we'll double click on the scope. As we can see, we have 3 signal input. The first one is yellow, which is of 1 frequency. The second one is of blue, which is of the 5 frequency. And the third one is of 10 frequency. But we are observing that the amplitude are certainly going different. This is because of the maximum step size. Now I'll make a changes in maximum step size. I'll tell you what is a maximum step size over here. When we go to the simulation and there is a model configuration parameter, when we click on it, we'll get a pop-up window. Over here, the signal is getting there and it's getting the values over a certain period of time, which is over here as auto. So the frequency is too fast to get the values as an output. So I will take I will change the value which is 0.01 and I'll apply it and I'll click OK and I'll again run it. After running it, I'll double click on it. As we can see, now the system is smooth. All the curves are smooth and the amplitude is always 1, right? Good. So now we have taken the input and know how to show as an output. Now we have to add the inputs, the three sine waves. For adding the sine waves, we have to take a summation. For summation, we have to go to the commonly used blocks. Over the commonly used blocks, we can see there's a sum. We'll drag and drop it over here. Thus, we can see there are two inputs of plus sign, but we have three inputs over here of the sine wave. So we again double click on it and we'll add plus one more and enter. See if it's little bit not in order. So in order to make it in order, just remove this line in the front and you click OK. So this gets into the format. Okay. Now let's connect all of these together. Sorry. Now let me tell you something. When it is connected to a certain wire, it shows a dot. When it is not connected to a wire, it will show a blank a line over a line. So we'll be able to know whether it is connected or not. Okay. So we have added all the three inputs. We have to show them. So for that thing, again we need a scope, right? So over here, we drag it and drop it over here. Okay. So then we connect it. After the connection, we'll run it again and we'll double click on it. As we can see, this is the sum of three sine waves. Great. Now let's export this value to Matlab. For that, let's go to the Matlab. Great. Now, directly, for that, we need a workspace over here. To export this model, we'll use a workspace. That workspace, we will find it in the sinks. In the sinks, there is a workspace. You drag it and drop it over here. Great. I have to give the variable name. Let's say sum underscore out. Okay. The name over here is sum out. So I'll select it to the output which I want to, and then I'll write it again. It is ready. Now when we'll go to the MATLAB, we can see in the workspace bar that sum out 1 cross 1 double. There is a value. Now we will give we'll plot this graph in the MATLAB itself. So for plotting the graph in MATLAB, I'll write the command plot sum underscore out. Remember that it is case sensitive, so be careful with it. Dot data and, and you enter it. Thus, we can see the output. It is as same as it was in the Simulink. Okay, is everybody clear with it? Please reply yes, or if not, please reply no. Thank you. So let's get going to the slide. And this is the model which we made right now, or project 1. Let's go to the project 2. which is integration and differential using Simulink. After this project, you'll able to overview, perform. There is a doubt. Is the output of convolution of three sine input? Yes, it is. Okay. Is there any other doubt? Shall I move forward? Please reply yes if I should move forward or not. Okay, thank you. So this next project is, as I've already said, integration and differential using Simulink. So after the project, you'll be able to learn how to perform differentiation and integration in Simulink, call a Simulink model from a M script, implement a mathematical and equation using Simulink. Okay, so I have taken already a mathematical equation for an example. So let's see what's the equation. Okay, so this is the mathematical equation I have taken, which is x by dt plus t of I integral of x dt equals f. For our convenience purpose, we have rearranged the equation, which is in the form of dx by dt equals 1 upon a, the whole bracket of f minus ti of integral of x dt. This is done simply to make our own convenience, right? So always keep in mind, if you have given an equation, always put the higher order of derivative over the left side. Great. So let's go to our page. You can open a new model as well, but I want to do it in the previous model as well because it takes time for my new model to open. So for that, I will delete the previous module and I'll simply explain the first how to do integration and differentiation in this model. So we'll again call the Simulink library. First, we'll do integration. When we integrate a constant, it always becomes a ramp function, right? So for that, we need an integrator which we'll found in commonly used blocks, which is over here, right? Integrator. We'll drag it, drop it over here. This is an integrator. Now we need a constant. Let's say 1. It's already value 1, so I'll give the value 1 itself only and we'll connect them. Now we have given the and we have given the mathematical operation which is integrator, and now we'll see what's the output. For output, we'll go to sync and we'll drag and drop the scope, as I have already told you what's the function of scope. Now we'll connect them and then we'll run it. After running it, we'll double click on the function. We can see it's a ramp function. And initial it is 0, but it started increasing. Like on the x-axis it's 4 and the value on the y-axis also 4. This is a ramp function. Great. Now let's do for the differentiator. So for that, if we differentiate a ramp function, it will always convert into a constant, right? So we'll select a ramp function from the scope over here. We'll drag and drop it over here and need a different derivative, right? So for derivative, I'll go to continuous, and over here the derivative is there and we'll drag and drop it over here and we need a scope. For copy pasting it, again I have told you also before that right click and drag and down. And again click on it on the scope. We can see there is a constant graph, right? Both of them. Let's say if we integrate the constant, it will become a ramp function. If you differentiate a ramp function, it will become a constant. Great. Does anybody have any doubt? I guess it's okay. Now we'll delete it. I'll make you go for the equation. The equation is dx by dt equals 1 upon a whole bracket of f minus ti integral of x dx. Okay, great. So let's get started with the second project, which is we'll take first two integrals over here. First integrator, right click, drag again. Second integrator, we this is how it goes. Okay, so we'll select both of them. Now I will tell you the value over here. Let's say over here the value is dx slash dt. How do I do it? I just double clicked on an area and I there was an option. I typed it and pressed enter. After the integration of dx by dt, we'll get the value of x. As x has a different functions, so we don't want that. We just want a notation over there. So add x annotation. See, the next. Now after integration of x, we want we what we'll get int of x, x, right? We got it, right? After that, we have to give an input. What is the input? Input is a constant, which is f. So for f, it is an input. It is a source. We'll go to source and we'll drag and drop the constant. See, it's written over here constant value, but no, we are going to click on it because there are certain times it might get wrong. So we'll just type F. We'll click apply. It will show that the value is not there, but I'll tell you in the coming time. Okay. After adding the constant, if there is a constant and there are other two things also, so for that we need a summation, right? For summation, we have to go to commonly used blocks. From commonly used blocks, we have to take a sum. And here it is. Okay. Now one more thing. Over here, we see there is an f and minus of ti, right? So I will have one plus and one minus. So when I double click on it, I'll change one sign into minus. So as we can see, it is plus and minus. Now, what is the thing we have to take in the minus? That is ti. Now we can see that the ti, the ti is a multiple of integral of x dt. That means it is a gain. For that, we will go to gain, which is in the commonly used block only. We'll right click on it over here and we need one more gain which is 1 upon a. So I'll right click on it and drag it over here. Right. I'll just add so you'll be able to know what is it. Now this direction opposite, for rotating it, you just type control plus R. It rotates. You rotate it again. So now it is what we have desired, that it should be in the left side. So double click on it to give the value. For value, it should be ti. Okay. Okay. So it should be integral of x. The value of integral of x is connected to over here. This value is going to be the minus, and the f it should be the positive, and this is the sum, and it should this part ti and fi integral of x is in the brackets, right? Now we have to give a gain of it 1 upon a. Okay, so for that I have added this gain, so I'll double click on it and I'll give the value 1 slash a. Okay, so we have given the value and we'll click it. So as we can see over here, the value is reexpedited. So we have made our first project, but wait, let me click it again over. For that, we have to give the output as well, right? For the output, we'll go to sync and take the scope again. And let's say I want the int x scope and not force scope. And I'll connect them both. Great. Now we run it. As we can see, the f file does not exist. A f variable is there. You don't know what's the value of f. The Simulink doesn't know. That is why it's showing an error. Okay. For that, I close it. For that, let's go to the Matlab. Now I'll give the values of f, a, ti, okay, over here in the editorial, right? Let's say f equals 2, a equals 3, ti equals 0.5, and we have given all the values. Now it's time to call the model in MATLAB, right? For that, we have a specific function which is sim. Sim is for Simulink. And then in single inverted commas, we'll write the name of the project. Over here, the name of the project I have taken as P. Good. So I'll just type P over here. And for saving this editorial, Control S, you know how to save it. .m with a .m extension. So I will write it in the chat box. .m. Okay. So this is how you'll save it. Now you will run project over here, which is if you go to editorial, you go to run. We can say it's a p test written in the command window. So again, we'll go to this and click on this. As we can see, there is an integration of x. And if we have to check the value of f also, here, the value of f we have taken is 2. And over here, we can see the value is also 2. Okay, this is the end of our project 2. Does anybody has any doubt? Please type it in the text chat box, please. So shall I move for the third project? Please reply yes if you want to. Okay, cool. Let's close the scope windows. Okay. This is what we made in the second project. Now let's go to the third project. Our third project is mass spring tamper system. After this project, you will know how to stimulate function in time domain in Simulink, learn how to derive simple mass spring damper system, how to derive mathematical equation using Newton's second law of motion, draw the free body diagram on Simulink model. I have taken a very simple example. Over here, we can see a mass of m. It is attached with a spring with a constant of k and b, which is a damper constant. Let's forget about the damper constant for a second. Okay, so if there is a mass and a spring, if we apply force on it, it will start moving to and forth, right? As we can see in the vibration profile down, there's a graph, right? So over there, we can say there is always a constant amplitude. But if we add a damper function over here, like a damper in this if we add it. So the amplitude always tends to go to zero. We can take it as an example in the car. When car is passing over a speed breaker, it gets over the speed breaker and it moves up and down. After some time, it doesn't move. Why doesn't it move? It does not move because of the damping over here. Okay, so everybody know what is the Newton's second law of motion, which is F equals m into a. F stands for force, m stands for mass, and a stands for acceleration. I'll take this example only, which is m. M is for mass, K is for spring constant, B is for damper constant, F is for force, and X is for the velocity in which direction it's moving. If we apply F force over a mass, it will start moving in to and fro. Okay, so we have this equation m x dash dash. X dash dash is the double differentiation of x equals f minus b into single differentiation of x minus kx. So we'll rearrange this equation for using it in Simulink model. So which is x dash dash equals 1 upon m whole bracket f minus bx dash minus kx. As I've told earlier also that always bring the highest order of derivative to the left side. Good. Now, so let's get started to make the model. So I'll call the library as well. Over here, first we'll delete the project 3. Deleted. Now let's get started. First, I'll need integrator. So we'll go to continuous. We'll need integrator 1 and integrator 2. Right. Now we'll connect both of them. And I'll again show you what is what. Over here, if we have a value of x, say dot dot, it is double differentiation. After single integration, we will find x dot. After again single integration, we'll find the value as x. As I've told, there are other many functions, but we are going to use x as a notation only over here. After adding the integral, as we can see the equation also over here, let me show you first. Okay. There is a gain of k, b, and m. So we need 3 gains. For getting a gain, we have to go to commonly used blocks and we drag and drop it over here. One we need it over here and right click on it and drag it down. You get another one and then the another one. Okay. Now I'll name both of them, right? We need like x into minus of k, right? So as this is in the opposite direction, as it is selected, we'll do control plus R, so it will rotate, and this one as well, control plus R rotated, and we'll double click on it, so it will show what we have to type is minus k. Enter. We can see it over here, it's minus k. Now we see that we need an b multiple of differentiation of x. So we'll click on it and we'll give the value minus b. Enter over here. And we can see the whole thing is multiplied by 1 by m. So over here, I'll double click on it and I'll give the value 1 slash m. Oh, good. So we'll connect the value of x to the b and we'll multiply the x dot to the minus b, and after this we have to connect all of them, right? And one more thing, we have a function f as a constant. For getting a constant, we have to go to the source. For going to the source, double click on it, single click and drag and drop it over here and double click on it. Just give the value as f. Okay. Now to add up all of these, we need a sum. For sum, we have to go to the commonly used blocks and here it is. We will keep it over here. Great. Now we can see that there are two inputs, but we have three inputs. So again, we'll double click on it and we'll add one more plus. Now we can see there are three. Now you can see they are unsymmetrical. If we want to make the signs unsymmetrical, then just remove forward bar over here and click enter. Now we can see plus plus plus. It is a symmetric form. Now just connect everything. Okay, so we have connected everything. Now to get an output, we obviously want scope. For scope, we want to go to sync and over here we have a scope. We drag and drop it over here. Let's say I want for x and I want it for x dot and I want it for x dot dot as well, and lastly for the constant f. Okay, now we connect all of them. If it doesn't connect, it will show like this red color. You just delete it and you directly connect it. We have connected all the four scopes. Now we can see this is red in color, right? That means it doesn't have the values for it. For that, we'll again go to the M script, which is Matlab over here. We'll delete all these values and again type it. There were values for F. For F, let's say equals 1. For B, let's take the value as 10. For K, let's take the value as 20. And lastly, for M. For M, let's take the value as 1. Good. Good. So, in order to call the Simulink, we'll use the function sim, and in inverted commas we'll use the p. Good. Now we'll again run it. As we can see in the command window, there's again a p test. That means it is run. So we'll go to the model again and we'll double click on it. As we can see, it has become an x over a certain of time, a straight line, which is over here. And for x dot, it is still like not a straight line. And for x dot dot, it's like this. And for a constant, if you want to check that your scope, your output is coming properly, so you can give a constant value and add a scope to it. As I have, you can cross verify it over here that f equals 1, and over here that f equals 1. So this is correct. So these these are the four graphs. So we have completed with our third project also. Does anybody has some doubt? Please write it in the chat box, please. So there are no doubts. So shall I move forward? Please reply yes. Okay, we'll move forward. We close all these models over here first. I'm sorry, what is the meaning of SS? Do you want a screenshot of it? Please reply to me in personal private message, please. I'm sorry, I'm not able to get your name properly. Some sanskar, please. Sorry about that. Okay, so this was the third project, right? Let's go to the fourth project. And this is the last project, and it is okay. We have a doubt what there is seen in the slope in the first peak of x dot dot. Okay, let me go back to it. It's because the function which we are getting it over here, it's again getting integrated. So if you click on it, you can see the values have changed a lot. Initially, before, like it was 1, but it get to, so the values have pretty much changed over here. Okay, Simulink. After this project, you're able to know how to simulate mass spring damper system in Laplace domain, S domain, which is S domain, and learn how to develop own mass spring damper system in S domain and understand the effect of impulse function. Okay, so let's get to the equation, I have taken the previous example only. Mx double dash equals f minus bx dash minus kx. Okay, this equation is in the time domain and we have to convert it into the frequency domain. It is done with the help of Laplace function, right? I hope everybody knows what is a Laplace function. If you don't know, um, I'm really sorry, I won't be able to explain what is Laplace function, but it is a part of your first year in the college. So I'll just directly tell what function which we have used over here. So if there is the derivative of x, and it's over here is at x double dash, that means you just have to put 2s square, and if there is a derivative of x, we put a single s, and we'll turn the x is in the time constant, and over here we'll change it into s domain, which is s, and m, f, b, k. These all are constant, so they will remain the same. So we have got it over an equation like ms square x of s equals f of s, and minus b of s x of s minus k x of s. Now we'll rearrange the equation up in the form of x of s by f of s, which is equal to 1 of m of s square plus bs plus k. We are going to use this equation, okay? And this is a form of control system. I was about to explain the control system, but it is 56 already, so I'm sorry about it. But you can learn about it on the internet. it's very clear. Okay, so this what we have made an equation is called a transfer function. Okay, which is of the form x of s upon f of s. Transfer function is a function of output upon input. Okay, so we are going to make a equation over here of a transfer function in the model. So let's get back to the model. I'll delete the previous model. For let's delete it. Delete this one also. Okay, now we'll bring the library. Okay, for a transfer function, we already have a transfer function component in this. So we'll just have to go to continuous. Then we'll find the transfer function, which is over here. We'll drag and drop it over here. We can see it is 1 upon s plus 1. It is of degree 1. But we need a degree of 2, as we can see over here. ms square plus bs plus k. In order to make it of degree 2, we double click on it. So we see the numerator coefficient which we need is only 1. But for the denominator coefficient, we need one more. So I click it and I'll add one more and apply OK. Now if you zoom out, we'll able to see s square plus s plus m. These are the degrees. So we have got the degree of s correct. Now we need the coefficients to be correct, which is m, b, and k. So we click on it again. So we'll delete this and we'll add m space b space k. Space is to know that there are the different coefficients. So we click on it. We can see it over here, which is m s square plus bs plus k. Now we need impulse function. An impulse function is a step function. So we go to source, and in the source we go to the constant. And no, sorry, not the constant. Please, we need a step function. So the step function, we'll use a step function over here, and we'll click on it. We'll give the final value as f, and we'll click OK. Now we'll connect them. Now to see the output, we'll go to the sink and take the scope over here and drag and drop it over here and connect both of them. Now the values of this are different, as I have saved it already over here. It won't show an error, but I don't want these values, so I will change the values over here again. I have to take the values as m equals 1, b equals 10, a equals 20, and finally f equals 10. Okay, so now we run it. Again, we can see there's a p-test again, so we'll go to this and we'll double click on it. We can see there's an output which we have got. Suppose we want a different output. For that, we have to change the values of this function, so we can see observe this. So let me change the value of b over here. Let me keep it 0.1 and be k as it is, but I'll take the value of k as equals 1. Now I'll again run it. So again we can see there's one more p-test, and we'll click over here on the scope. As you can see, the output has changed. So accordingly, what's your coefficient, the output would change. So for here now, we have completed our fourth project as well. Does anybody has doubt? Please write it in the chat box. This is the last project what we have made. So nobody has doubts. Okay, so this is our what is Matlab and Simulink used for? As I have told you before also, it is a fundamental tool for engineering and scientific work. So it's basically used for research as well as MATLAB is used for research as well. Simulink also used for research. And, and as we have done in our um, first year's thing that the math thing, how to integrate, and nobody doesn't remember it, but it is pretty much used in scientific and research work. Thank you. Does anybody has some other doubt? So here it is, our feedback form. I'll just copy it and paste it in the chat box. Please do fill up. Here you can see the okay. Thank you so much for your time. If you want it, so please, I'll write you my email address. I can give you directly over there. You can find it in the chat box. Thank you so much for being present in this. So, thank you. Does anybody has any doubts? So, if not, so we can close it. I guess no one has any doubts, so we'll end the session. Yeah. I can give the PPT itself. If you have any other doubt, you can just email me. I'll clear it over you to them. I don't have the recording with me. Okay, so I guess that's it. That was our last session of our series ABCL. I hope everybody liked it. Thank you so much.